But the reason I mentioned that also is our next speaker, who is a person who has donated a lot and helps us get this Pecha up on the screen for you and on Channel 8. Our next speaker will be William, otherwise known as Bill the Thrill Decker. No, I'm just... He graduated from Virginia Tech. Actually, he was asked to leave Virginia Tech. No. He graduated from Virginia Tech, was employed by IBM for 36 years as an electrical engineer, programmer. As a hobby, Bill collects and restores automatic musical instruments, which may perhaps be the subject of a future Pecha if you treat him nice tonight. If it goes well, he'll be back. If it doesn't, bye Bill, goodbye Channel 8. He volunteers at Longmont TV Channel 8, where he tries to teach video camera operation and video editing. He's also a member of the Eyes on Longmont production group. One of his projects is to put Longmont Pecha programs on Channel 8. Bill is, his exact words, I'm not being hateful, I'm not being mean. Bill is a nerd. And proud of it. Fellow nerds of America, stand up. His presentation tonight will be nerdy. No, I'm sorry. Why does my printer only have cyan, magenta, yellow, black ink, or how to upset an artist in 6 minutes and how many seconds? 40. Perfect. I now give you Bill the Thrill Decker.
So the real question is, how can I print such beautiful pictures with my printer when it only has 3 lousy colors in it? And the answer to the question is, it's based on how human sight works. If you remember from your high school science classes, the retina contains rods and cones which are light sensitive, and the rods are primarily used for night vision and have no color sensitivity, but the cones have sensitivity to only red, green, and blue wavelengths. So if you can control the red, green, and blue, you can control any color. You can generate any color. So if I take 3 spotlights, a red one, green one, and a blue one, and shine them on the screen, you will see red, green, and blue, as you see here. But if I move those spotlights together so they overlap, you start seeing additional colors. You will see yellow where red and green mix. There is no yellow on that screen. It's just the way your mind interprets the mixture of red and green. You'll also see cyan and magenta, and you'll see white in the center where all 3 colors mix. But the only colors really on the screen are red, green, and blue. Now, this is how your color TV works. Believe it or not, your color TV only has 3 colors, red, green, and blue. Well, let me back up here a little bit. You can make any color by changing the intensity of the red, green, and blue. Like 98% red, 75% green, 39% blue will give you that orange that you see in the center where the 3 overlap. So with your television only generating red, green, and blue pictures, if you take the blue picture and the red picture and the green picture and project them on the screen on top of each other, what your mind will see is the picture in the lower right-hand corner, full color. Yet there are colors there which do not exist in the red, green, and blue picture. So, complement colors. What are the complement colors? The complement of red is cyan. The complement color is the color you see when you remove that color from the red, green, blue mix. In other words, if you have white and you remove the blue, what you'll see is yellow. If you remove green, you'll see magenta. If you remove red, you'll see cyan. So yellow, cyan, and magenta are the complement colors of red, green, and blue. Yeah. So how do we print on paper? You start with a white piece of paper with white light shining on it. And what you've got is already the maximum amount of red, green, and blue that you'll ever get, because as for the definition on the previous screen, white is a mixture of red, green, and blue light. So how do you control the color? You do it by removing quantities of red, green, and blue. Remember, we're trying to control how much red, green, and blue we're seeing to create a color. So if I print red and green and blue inks on a piece of white paper, you will, of course, see red, green, and blue. But if I overlap those printings, you might be surprised at what you see. You see black, because red is removing green and blue light, and green is removing blue and yellow light and leaving the green. So when you overlap any of those colors, you'll see no light at all, which will be black. So they're the wrong colors to use for printing. So what we need for printing, we need colors that remove only one of the red, green, and blue colors instead of two. And those colors are the complements of red, green, and blue, which are cyan, magenta, and yellow. So you see, if you print magenta on top of cyan, you'll see blue. Magenta on top of yellow, you'll see red. Yellow on top of cyan, you'll see green. This is really, it's called subtractive color system. You know, when you mix light, it's additive color. This is negative color, subtractive. So to calculate how much cyan, magenta, and yellow to use, here's the orange that we created before. We said we need 98% red. So you can mathematically complement, just like since there are complement colors, mathematically you can just complement them. And so to get 98% red, you put down 2% cyan. It leaves 98% red. To get 75% green, you put down 25% magenta. And to get 39% blue, you put down 61% yellow. So why do we have black ink in our printer? Well, most of the time we print black, so we can save ink by just using the black ink. Black is less expensive than color ink. It takes 3 times the ink to try to print black with cyan, magenta, and yellow. Now I'll just touch on black substitution. It's best explained by example. If I had a color that I want to print that takes 20% magenta, 40% cyan, and 60% yellow, there's a 20% gray component in that color in the center there. So I can reduce all the inks by 20% and end up with 20% cyan, 40% yellow, and no magenta at all. But I have to replace the gray component, so I print 20% black, and then I'll end up with the same color. And what I've done in the process is to use a lot less ink. It's called toner saver. So, but if truth be known, you really get better pictures if you use the black. So here's the things that patents are written on. If I print this yellow, this cyan, this magenta, and this black on top of each other on a piece of paper, what you will see is none of these colors, as you see here, you'll see a full color photograph, which is in the next slide. So in controlling the amounts of red, green, and blue that you see, we can control what colors we are presenting to you.
Now you see your printer in a different light, right? Okay. What was that percentage he was saying we had to work with to get gray? 20. Right, all right. Okay, folks, moving along.